Hello, everyone, and welcome to my class. Today, we will be talking about simplifying radical expressions. This is part of the 7th grade curriculum. I really don't know at this point. It's probably 8th grade or 9th grade stuff, but I'm just going to put it as 7th grade so people don't get freaked out. So, our schedule today. First, we're going to go through a review. It's going to be quite a short one today. Since we're only talking about square root functions, but we do need to get out Desmos. And then we are going to be simplifying radical expressions, and then lastly, problems. Yes, we all need a little bit more problems, yes? Yes. All right. Why the heck is there 12 comments already? Crazy, is it? What the heck? What does that mean? Is that Japanese? Demon Slayer? That's an anime, isn't it? Oh. Naruto is better. All right. Square root functions. All right. Yes, square root function. So what is the parent function? All types of functions have a parent function, which is the simplest form of our function. And in this case, the parent function is y equals the square root of x. That is our parent function. Hold on a second. People usually write it fancily like this. Oh, that looks much better. I need to practice my x like that. Oh, that looks nice. A little bit slanted. Oh, yeah, that's good. All right. So, okay, this X is too hard to write. I'm not going to try. All right. So let's take a look at what square root functions look like. All right. So, square root functions where y equals the square root of x. So basically, y squared equals x. So, let's say x is 0, and then y would be 0 as well. And then what? 1, x is 1, and then y would also be 1. Okay? And then let's say x is what? 4. Then y would be 2. X is 9. Y would be 3. Okay, it's just y is the square root of x. All right. So let's take a look at what square root functions look like. Desmos. All right. So a square root function. Okay, what's the parent function? Okay, y equals the square root of x is the parent function of this, and it kind of looks like this. All right, this is a square root function, and as you can see, it increases very quickly in the x-axis, but it also increases very slowly vertically. So the y value isn't going very high because square roots and stuff, they can like exponents, okay, exponential functions and square root functions. All right, they can grow very fast one way and then grow very slowly the other way, usually like that. Okay, so now let's take a look at the parts of square root functions. Okay, parts of a square root function. Who can remember what the full square root function is? Okay, if we have a square root function, and as you know, like exponential functions, all these, okay, there's a parent function, and then we can add to that parent function with all these other attributes. What is the full square root function? Who knows that? No one? Oh, that's very sad. Certainly didn't take notes or what. Yes, let's see. All right. Fx equals square root of x. Okay, that is the parent function, Stephen. We need the full square root function, like a values and c values, that kind of stuff. You know that one? Okay, I'll give you a moment to think about it. So no one knows the answer. That's extremely sad. Oh, Stephen. I assume that's the answer. All right. I'm afraid that is incorrect, Stephen. The full square root function is going to be fx, no, fx equals a times the square root of bx plus c plus d. Okay, so c is in the square roots, d is outside. So can you recall what these attributes mean? All right, what does a do if you change it? What does b do if you change it? What does c do? What does d do? All right, okay. And then so let's look at a. What does a do? Okay, does anybody know what a does? Okay, when we change the value of that. So let's add an a value here. All right. Okay, we add an a value here. And you see a kind of, if you change it, okay, let's just change it a bit. Let's animate this. It kind of shifts vertically, right? It kind of changes the y, okay? It still increases in x the same way, but kind of the increase in y changes, so it is a vertical, shift. And you see here, you notice when a is negative, okay, when a is negative, the graph becomes, the y value decreases, okay, and it's negative. All right, so that is what a is. So a is a vertical stretch. Okay, it is a vertical stretch. All right, so a is our vertical stretch, and when a is positive, which means it is greater than 0, you see the graph is kind of like this, and when a is negative, the graph kind of goes down. All right. So now let's take a look at B. B is also a vertical stretch. All right. So for those now joining us, okay, new students that haven't been to last class, please write this down because there's been a lot of participation today, right? No very quick answers, huh? All right. So actually, let's take a look at what B does first in Desmos. So let's get rid of this. Actually, let's keep that on. Put it at. Let's keep it at 1 first. Right. It is 1 right now. All right. Okay. So now let's look at B. So remember, our full function is a times the square root of bx plus c plus d. So b is in front of x here. And since it is taking the square root of b times x, you see, okay, when you animate this, it's still a vertical shift. But you see here, when b is negative, it actually changes, it reflects over the y-axis, okay? When b is negative, it reflects over the y-axis. So let's pause that. When B is positive, we should have this. When B is negative, we should have this. All right. So that is A and B. Now C and D, these are just extras. You usually don't need them to change the graph that much, but this can change the positioning of your graph. And usually, with our experience with vertex form and all these other functions, okay, usually H or K and C and D usually change the position, the X and Y. So C here, you can kind of guess, is going to be a horizontal shift. All right. So C is a horizontal shift. Okay, it is a horizontal shift. And then let's take a look at what C does here. All right, so let's add a slider here. Okay. So let's animate this, and you can see that when C changes, the graph is just going to shift horizontally, okay? But here's a weird thing about it, because when C is negative, right? When C is negative, okay, it actually moves to the right. And when C is positive, it actually moves to the left. Okay, that's one weird thing about it, and you should definitely take notes about that. So, horizontal shift. When C is greater than 0, which means it is positive, it actually goes to the left. When C is less than 0, which means it is negative, it goes to the right. All right, so let's take a look at D now. D, since C is horizontal shift, D should be vertical shift. All right, so a vertical shift. So D, let's take a look at D. Okay, let's add a slider here. So D. Let's reset that. So D, when it increases, the graph shifts upward, which is that makes sense, right? When D increases, basically, since our y value is this function right here, when we increase the D, that basically just increases the y value, so that makes sense. Okay, and when D decreases, well, the graph moves downward. All right. So this is all the attributes of our square root function. So when D is greater than 0, the graph shifts up, and then when D is less than 0, the graph shifts down. All right, so does anybody need any time to take notes on this stuff, or are we all down with these notes? Are we all done with these notes? Okay, do we understand this information? This is a review, so could be pretty familiar. So no one is saying anything, huh? It's very sad. Are you all dead or something? I'd be very sad if you were all dead. Come on, say something so I know you're not dead. Oh, you're dead. Wait, since when did dead people talk? Oh, you took notes. All right. No. Okay, when you're dead, Edward, and this is exclusive lessons from me about being dead. All right, when you be dead, let's say you are shot. Okay, once you are shot, you say "Ugh," and you die. Okay, you do not say I did. Okay, you and then you splatter a lot of blood, and then you die. Okay, if you're stabbed with a knife, then you don't say anything because you say you just splatter blood and die. Okay, yes. You do not say I dead when you die. You say ah or something like that. Or you say ouch and then die. Very classic. All right. Exclusive lesson over. We're now going to return to the topic since you guys are not dead anymore. Okay, so let's talk about finding the domain and range of square root functions, all right? So the domain and range. Okay, let's say we have a problem here. Okay, we have a function here. Fx equals 2 times the square root of 3x minus 9. All right, the square root is a bit crooked. I'm going to fix that real quick. All right, it's still crooked, but okay, whatever. 2 times the square root of 3x minus 9. So let's review domain and range real quick. Domain is all the possible x values. Okay, so domain is all the possible x values. It can go from 3 to 6. Okay, it could go to 0 to infinity. Okay, so range is all possible y values. Okay, that makes sense. All right, so now we know what domain and range is. So first of all, we need to look at domain. That's more important when we're looking at domain and range. And once we have domain, we can look at range. Okay, so let's go to domain real quick. Okay, so let's look at the important part of this function. When we're looking at domain, we look at the stuff inside the square root. Okay, the stuff inside the square root, we look at that. So what is that? Okay, 3x minus 9. Okay, that is the stuff inside the square root. And what makes this function not true? Okay, so this can be any number except for negative numbers, because since we're working with a square root here, we have to keep in mind that we cannot square root a negative number, and that's going to be a major obstacle when we are graphing these functions. So we cannot have them being negative numbers in the square root. So 3x minus 9 must be greater or equal to 0. Okay, and when have we seen this before? This is an inequality. Okay, so and we can just solve this. And then we can find what x is. All right. So let's solve this real quick. So 3x is greater than or equal than 9. Okay, so x is greater than or equal to 3. So that is going to be our domain here. Basically x is greater than or equal to 3. It's basically 3 to infinity. All right. And then we can look at the range. Okay, and the range is very simple once you have the domain. So the range, let's look at this. We have y equals 2. Okay, so basically we just sub in 3 for x, right? We just sub that in for x. So we just sub that in. Okay. And then y equals, you see here, it just equals 0. Okay. 2 times the square root of 0. All right, it's just 0. So then y can be greater than or equal to 0. Basically 0 to infinity. So that is our domain and range, how to find them. All right. So does anybody want to take notes on this, or are you already done with notes? All right. Already done with notes. Are there any questions? Okay. I'll go back here. Phew. Choked on some water. Are you done yet? This is very easy, okay? Be faster. Oh, and I don't need this anymore. Okay, you're done. Kaishi, are you done? Okay. Yes, that's good. All right. Simplifying a radical expression. Yes. So let's do some warm up questions real quick. Let's just do some warm up questions. All right, this easy stuff, you know. So, this is just with numerals. Okay, so let's just simplify this. All right. Okay, just simplify this. Okay. Simplify these fractions. All right. Okay, so this should be extremely easy for you guys. Well, it's not going to be easy later. Well, probably for Steven, yes, that would be very easy for Steven still. But we are going to be including variables and stuff, okay? It's not just going to be numerals, okay? It's going to be more complicated radical expressions. But this is just for reviewing how to simplify them. All right. So I'll give you a few moments to do these two problems, and don't just give me one answer. I want two answers, all right? All right, let's take a look at the answers. Two answers, huh? Or maybe it's just one person spamming the answers. This is very sad, guys. Only Edward and Steven, huh? So you guys don't know how to simplify fractions? All right, that's a national emergency. Wow. How old are you guys? Don't know how to simplify fractions. Well, all right. 18 over 30. Okay, so this you can do mentally, all right? But when we're working with bigger things, we need to factor, all right? We need to factor. So what is 18? Okay, what is 30? What are the GCFs of 18 and 30? Okay, for these small ones, you probably don't even need to. We can just take a look at it and know the answer. But this is good practice. So it's 6, right? It's 6. So what is 18? 6 times 3 over 6 times 5. All right. Here, 6 is canceled out. Okay. Basically just equals 3 over 5. All right. And 17, same thing. What is the GCF of 17? 68. Well, it's going to be 17. 17 times 1 over 17 times 4. Okay. Canceled out. 1 over 4. Okay, so that is how you simplify them. Are there any questions on that? Any questions? Well, it's so boring that even Genevieve left. That's very sad. All right. No questions. Okay, good. So actually, let's not do that. We still have more to do. Yes, we still have more to do. So let's erase this. What the heck is this? Erase touched area. Erase line by line. Let me experiment with this. Okay. Erase all. Hello. This is pretty fancy. No, it's probably not, but it's okay, I'm just gonna erase line by line real quick. Yeah. Okay, back to the subject. So let's take a look at something a bit more complicated, but not the hardest we are going to do. 10 n squared over 5n to the fourth. All right. Who can do this problem? Who can do this problem? All right. Does anybody know the answer to this? 2 over n squared. Okay, this is gonna be sad. Stephen and Edward are correct. I see 2n to the negative second exponent. Okay, that is correct. Except it's not simplified fully. We are simplifying. Okay, negative exponents are not allowed. We learned that in the exponents class. Okay, so simplify the negative exponents. 1 over n squared, and then multiply by 2. Then it'll be 2 over n squared. And then Kiki has the correct answer. All right. We're done here. Everybody knows the correct answer. So how do we do this? Okay, to clarify, okay, let's just split this into two fractions. Okay, two radical expressions. Okay, it's basically 10 over 5 times n squared divided by n to the fourth power. Okay, so what do we have here? Basically, 2 times n to the negative second power, which is 2 times 1 over n squared, which is 2, okay, that's a bit big, 2 over n squared. All right. That is our answer here. Okay. Are there any questions on this? Any questions? No questions? All right, so now let's look at the excluded values. What the heck just happened? I just turned on the video accidentally. Do you want me to turn it on again? Oh, too bad you can't see me, huh? All right. So, no, I'm not turning it on. Oh, I turned it on here. Oh, accidentally turned it on. Hello, people. Hello. Can you see my hand? Oh, there it is. Hello, people. Hello, 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 hello. Okay, bye. All right, so no pleases. All right, no pleases. Where's my Kylo Ren mask? All right, Kylo Ren mask. All right, here it is. I will now turn on my camera. All right. See? So good. All right. Okay. We're done here. We are okay. Yes, of course I'm a boy. What do you mean? I haven't reached puberty yet. The voice hasn't deepened. Hello. What does Zoom do? You make my voice sound so young. It's the mic. Kids nowadays. Of course I'm a boy. Okay, I'm 12 in real life, but the the mental age is 6. Really, I'm turning 7 in a few months. Yes, I know I sound like a 5-year-old kid. Yes, I haven't reached puberty. All right, shut up. All right, so now we are going to learn about excluded values. All right, excluded values. N does not equal 0. Okay. Why? Excluded values basically means, pen, what's wrong with it? Okay, excluded values, okay, where the denominator equals 0, okay? The denominator equals 0. Why can we not have the denominator equal 0? Because anything divided by 0 is unidentified, right? It's unidentified. So we cannot have that. Yes, of course I'm a boy. Yes. Yeah, can you shut up already? What's wrong with this mic? Do I need to switch one? Anyways. So excluded values. Let's look at this. What can we make? Okay. What can we make n? So it's 0, okay? We can just, it's 0, right? It's just 0, okay? It can be 0, okay? So n does not equal 0. Because if it's 0, then the denominator is going to be equal to 0, which is unidentified. All right. Examples. Sad. I know. It's very sad. Wait, do we even have time for problems? No, we do not have time for problems. All right, just do this on your own, kids. I'm trying to do a job here, okay? So who can solve this? No one. Okay, I'm just gonna walk you through this. Basically, you factor, you factor, okay? Like what we do in mathematics, okay? You just, why does this circle look so bad? A factor, and then factor x minus 2 over x minus 2 x plus 3, okay? And what does this do? You cancel out, okay? You cancel out, kids. Common sense. Voila. Why am I even teaching this? Okay, 3 over x plus 3, and then you can't simplify this anymore because this is the whole factor. You can't just divide by 3 and be good, okay? No. Example number 2. All right. Oh, you're being smart over here, okay? What is this? Difference of squares, okay? And you just simplify, like what's this? Okay. What was this bouncing up again? The stupid thing. Okay, 2 minus x, okay? And 2 plus x, okay? And then we're done here. Okay, just simplify the rest, okay? So x, what is this? Okay, minus 2 and then x plus 6, okay? We factor already. And then hello. How do you do this? Okay, you factor already. So I need to take a look at my notes. Okay, how do you explain this to you guys? Actually, I think we're already done over here. Yeah, we're already done over here. Actually, I don't think so. Hold on a second. I think we can Yes, we can do something with this one. Because, let's take a look at this. Okay, let's take a look at this. What does this look like? What does this look like? Right? Okay. No, actually not this one. The other one. This is the exact opposite of this. What can we do to make it opposite? Divide by -1. Okay, so then we can simplify. -1 times x minus 2. Okay, and then we done already. Yes, okay, and then simplify. Okay, and then now we're done. Okay, so this is basically -2 plus x over x plus 6. All right, so what are excluded values? We have 2 right here. Because look at the denominator, okay? We have 2, okay? 2. And in case you're blind, we have 2 excluded values. All right, so x does not equal -6, and it does not equal 2. All right, we're down here. So multiplying and dividing, any questions? No questions? All right, no questions. All right. So, also, multiplying and dividing. We are now looking at multiplying and dividing. Yes, very fancy indeed. So let's look at multiplying and dividing. Actually, do you even have? Yeah, a little bit of time. All right, I'm gonna have to rush through this. Okay, so let's look at some examples over here. Okay, 2x minus 14 over 4x minus 6 times 6x squared minus 13x plus 6. All right, how do we do this problem? And what do we do here? Okay, let's look at an example. An example within an example. All right, 2 over 4 times 2. Okay, that's basically the same format. What do we do here? We multiply the top. All right, so let's simplify this first, and then we just multiply on the top. All right, so what does this equal? Okay, this equals, let's simplify first. All right, yes, very fancy indeed. All right, 2 times x minus 7 over, okay, 2 times 2x minus 3. All right, okay, we're all clear with that? So now, and then we factor this. All right, so let's factor by grouping here, okay? So 6 times 6, which two numbers multiply to 36 and also add up to -13? Which two numbers? Right. These two numbers are going to be 9 and 4, -9 and 4, and -4. All right, so then we have 6x squared minus 9x minus 4x plus 6. Okay, now we just factor by grouping. All right, so after we're done with that, okay, we just copy over here. Over 2 times 2x minus 3 times, okay, just factor out the GCF of each one of them. 3x, actually 2x, 2x, okay, 2x, and then minus 3, okay? And then for this one, okay, you factor out what? -2, okay, you factor out -2, and then what? 2x minus 3 again? Okay, so we're done here. Basically, it is 2 times x minus 7 times 3x minus 2 times 2x minus 3. All right, we are done here. Over 2 times 2x minus 3. So after we're done with that, we can cancel out a lot of things. 2, okay, 2x minus 3, 2x minus 3. And then we just have x minus 7 times 3x minus 2, a nice little factored form of some what square quadratic expression. Yes, very nice. All right, we're done here. Okay, so now what are we doing now? What about the division part of this? Okay, so multiply. Oh, actually, erase off. Actually, did I do that? No, I did not do the excluded values. But anyways, I remember the denominator. It's what? 2 times 2x minus 3, okay? We just look at the denominator. What can x not be, okay? It's basically x cannot be equal to 3 over 2. Okay, we're done here. So, dividing. Let's move on to dividing, okay? Dividing, okay, basically that's just multiplying by the reciprocal. Okay, just multiply by the reciprocal and you're done already. Okay, so x squared minus, okay, that's too far to the right. X squared, oh, that's bad handwriting. X squared, that's even bad. That's even worse handwriting. X squared, I'm not even using a pen. X squared minus 25 over 4x plus 28. What is that? A 3, is it? 2. Okay. Divided by x minus 5 over x plus 2 times x plus 7. Okay, just factor already. What are you doing? Lazy, is it? Okay, factor. And then what is this? Difference of squares. Okay. Okay, so now we do x plus 5, x minus 5, okay, over 4 times x plus 7. All right, what is that? That's going to be basically times the reciprocal of this. So basically, x plus 2 times x plus 7, okay, over x minus 5. Okay, we're done here. So, what do we cancel out? Well, boom, boom, bam, bam. We are done here. Actually, are we really done here? Voila. Yes, we are done here. Why does this freaking pop up every time? So annoying. Right. Okay. X plus 5 times x plus 2 over 4. Okay, we're done here. Oh, and no excluded values for dividing, because when we are dividing and then we have the reciprocal, it's very confusing, all right? So we don't need to do the excluded values for this one. All right. So now problems. I'm not going to help you on this, all right? I'm not going to help you. You do yourself, okay? I'm just going to chill. Chill already. I'm going to be here. Okay. -5. Did you just say -5, huh? Oh, you just said -5. Oh, wait, you're correct. I think you are correct. I was mighty sad. Hold on a second. What? No, you are not correct. Wait, actually, you are. Wait, what? You have one answer. -5. Okay, it's -5. Oh, apparently it is -5. All right. Damn fast. All right. Wait, did I just say the D word? Oh, whatever. 5m minus 10 over 2. 5m minus 10 over 2 minus m. Okay, what do we do here? Factor first. M minus 2. over 2 minus m. Okay, and then we just do negative 5 times 2 minus m over 2 minus m. It's just negative 5. All right, you're done here. Okay, this one. Take your time with this one. I'm not helping you unless I walk through it, which I will. That would be very sad. All right. Does anybody have the freaking answer? Well, okay. No answer. When did you get so slow? Oh, kids nowadays. Oh, one comment. Two comment. What the heck? That's your answer? Okay, that's your answer? Is that your answer? Are you sure that is simplified? Okay, what did I say? I did not say a cube. If this were a cube, even if it were a cube, it wouldn't be like this rectangular prism. Okay, read the thing. Okay, kids nowadays like don't read it. Actually, I have a kid too. Never mind. This is simplified praise the kids nowadays not read it. I did not just mute. I think your ears just went deaf. Or did you just leave the audio? I don't know. Alright. So, can you all hear me talk or not? Or are you all just dead as usual? Just dead as usual. Alright. Alright, okay. So the correct answer is W plus 4, kids. It's W plus 4. It's very simple. What do you do? The volume of the prism is 3W cubed plus 17W squared plus 20W. What's that? Okay. Over, okay, because we need to divide by the length and the width to get the height. Okay, so what is that? W times 3W plus 5. Okay, we are done here. Done already. Now we just need to simplify. Okay, so let's simplify this top first because we need to factor by grouping, which is very annoying. So let's do that. Okay, so where is this? 60, right? 60. Okay, so which two numbers multiply to 60 and add up to 17? Okay, 60. Okay. Oh, this is quite hard. No, it's not. It's 5 times 12. All right, so 3W cubed plus 12W W squared. 12W squared plus 5w squared. Okay, why is my hand shaking like this? Squared plus 20w. All right. So after we factor by grouping, 3w squared times w plus 4. Okay. Then plus k 5 times, okay, find w, 5w. Okay, 5w. Okay, just what is this? W plus 4 again. Right? W plus 4 again. And then what do we have here? We have W times hold on a second. 3W. Oh, voila. Wait, since when did we have that? 3W squared plus. I see the problem here. Okay. We also have this. I see. Okay. So we can simplify further with this actually. I see. I missed something. Okay. 3W. Okay. No. No. We need to do W actually. Okay. W times. Okay, because this is basically what W squared and 5W. Okay, it's just W. W plus okay. Wait, did I just erase the 3? A 3 is right here. Okay, 3 is right here, yeah. Alright, so then hello. Why is this pen so annoying? Okay, 3W plus 5. Alright, and then lastly just W plus 4. Okay, so and then we can just take that W times 3, W plus 5 times W plus 4 over W times 3, W plus 5. Cancel, 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 cancel. Answer is W plus 4. Okay, we are done here. Any questions? You're not dead. Okay, that's good. Nobody likes a stinky dead wombat. Oh, yeah, and this is the last problem. Have fun with it. Are you freaking done yet? You're not done. That's incredibly sad. Okay, I'm just gonna go back. Go back. You're not. This is very sad. Too sad. So sad. So sad indeed. Very sad indeed. Too sad. Hello. All right, kids, are you even done yet? Two answers. Okay, let's see here. Correct answers or not. What? Huh? Let's see if your answer is correct. We will see. Are you sure your answer is correct? Because I'm not sure your answer is correct. No? Alright, this is bad. Okay. No, never mind, your answer is correct. Okay, so now let's start solving this one in case you haven't already. C plus 3 over what? C plus 8 C minus 7. Okay. Oh wow, this is cricket. Cannot be cricket. Alright. And then we just multiply the reciprocal of this. Reciprocal. And then a factor by grouping again. Factor by grouping is very troublesome because it takes up a lot of space. Y'all need a little bit of that, don't we? So 2 times negative 21, what do we get? We get 42, and then two numbers, negative 14 and 3. All right, we are done here. Excuse me, why do you always pop up and tap to play the last song? When did I listen to songs? Are you dumb? Retarded? Why do you not go away? Not go away, is it? Oh, there you go. Bye. Have a fun time dying. All right, so 2c squared minus 14c, okay, plus 3c minus 21. Okay, this line needs to be bigger. Why the line so short? All right, so, and then lastly, we have the 2c times c plus 3, okay. What can we eliminate from the very start? C plus 3. Let's just eliminate that first. Okay, so 1 over c plus 8, okay, times c minus 7. Let's just eliminate that real quick. All right, and then times. Okay, we can just simplify this. Okay, what will we get? Okay, 2c plus 3 times c minus 7, right? Okay, that's what we get. Okay. Wait, is that correct? Wait, I don't think that's correct. I need to check that again. Okay, so this group factor thing. Okay, what can we factor? 2c is it? Hello. No, it is correct. Plus 3 c minus 7. Okay, over 2c. Okay, we're done here, and then I'll just cancel out all this stuff. Why do you always pop up? Okay. 2c plus 3 over case 2c times c plus 8. Alright, I think we are done here. Yeah. Alright, so that was our last problem. Okay, yes. That was a nightmare. Yes, it was a pretty bad nightmare. And also, Stephen, yeah, you are incorrect, Stephen, and Maggie, you are also incorrect. The only person correct is Edward because he added parentheses, and you can't just divide by, yeah, that's just sad. I know. Yes. Yes, you need to add parentheses to be correct because what? You only divide by one thing, you need to divide by the whole thing, okay? Right, we're done with this class. I'm out of here. All right, bye, kids. Yeah.